let's start with the basics of exponents. Anything to the 0 power is immediately equal to 1. Now, for something like, say, 17x to the 0. The 17 is 17 times that, and it has an exponent of 1. Therefore, the x to the 0 becomes 1, and it becomes 17 times 1, which means the answer is 17. So be careful of that kind of a setup. Here, number 2, this is where you add those together. When you have the same base, x here in this case, then that means the exponents can be added, so you have x to the 8th. Here is an example where it's not that, where you would multiply. What you really have is this 3 times. That's what an exponent of 3 means. Of course, that's 5x's there, and 5x's here, and 5x's here. So that means 5 plus 5 plus 5 is 15. Much easier to multiply. But that's why you see the difference in the rules between these two. And the format, when it's an exponent of an exponent, you multiply. When they're exponents of bases, you can add them if the base is the same. A negative exponent just simply means automatically that you take it from the numerator and you move it to the denominator and you change the sign. If it was negative in the denominator, I would move it up front and up to the top to the numerator and make it positive then. And because there is always a 1, silent 1, you can have a 1 there because there was a 1 here in front of it. So when the x to the negative 2 went to the bottom as x squared, that 1 remained there. A note about this: final answers may never have a negative exponent. Always change or move, always move the variable that has the negative exponent and make it positive in order to give a final answer. I will write that. Final answers in any type of problem you give me and throughout the entire year must be changed so they have positive exponents. They only have positive exponents. Here is an example where the next one, where we would bring the x to the negative 2 up to the top as the numerator. There's no reason to even put a 1 underneath it. That silent 1 that's down there, every number has a 1 underneath it. It's just that we're at x squared. Here, there are 2 of these and 9 of those. I would bring these down here as x to the negative 2 and have it 1 over x to the 7th power. I would, and you should too. Aha. One thing you can do with negative exponents is just simply move them. So one of the things I could do is simply switch them both. Then I can see, oh, there's 9 of these and 2 of those. If I bring this up here again as x negative 2, or I could have left the x to the negative 9 or the x to the negative 2 there, and I'll show that in a moment. That means that that's going to be an x to the 7th. What I could have done was to have left it x to the negative 2nd, brought this one up top, made it x to the 9th, negative 2 plus 9, or 9 minus 2, would have been the same x to the 7th power. All right, here, we're cubing this. That means, and watch out, that is not equal to 3x cubed. Not. The reason is because that 3, the exponent 3, has to apply to each thing because it means it's 3x times 3x times 3x. That's what the exponent means. So we have 3 cubed, which is 27, and x cubed. Number 9 is the same thing, essentially. You can do xy times xy times xy times xy, or you can apply the 4 to each one. There's a 1 and a 1 for both of those, so it's 1 times 4 and 1 times 4. So it's x to the 4th and y to the 4th. We could have done that up here because that was a 1 with the 3. 3 times 1 is 3, so 3 cubed, there's the 27, and x cubed, there's the x cubed. On this one, we're going to apply that to each one of these because all of these have an exponent of 1. So what we really have is 3 cubed, x cubed, 4 cubed, y cubed. Don't really need the parentheses anymore, but still. 27 x cubed 4 times 4 is 16 times another 4 is 64y cubed. 3 cubed is, well, let's get this right, is not considered simplified. That means you have to actually give the number. If you were to leave the answer with 3 cubed in it, I would have to mark it wrong. So make sure you are careful about that and do not accidentally leave it. You actually have to multiply out. 3 cubed is not considered simplifying. Same with 4 cubed, so you actually have to multiply it. Now there are two choices here. One, we can apply the -3 to each thing, and then switch them all around to get 4 cubed, y cubed, 3 cubed, x cubed. Or the second one is, because of that negative, immediately just switch them all and take away the negative. Now this becomes a more, comfortable problem in a way. But either way is acceptable, just as long as you keep track of the numbers that you're using and don't get any wrong. Okay, now down here, yes, on here, we're going to do essentially the same thing. Well, no real difference, but we're going to multiply to each exponent, the one there. So that's x to the 5 times 2 is 10. 2 to the 5th power is 32, and 4 times 5 is 20, so it's y to the 20th. That illustrates, or all of these illustrate, the basic rules of exponents that you should be aware of and you should be able to use. Anytime you see a negative or the fraction or parentheses with exponents, you know what to do with them. All right, let's look at some of the operations. This first one is multiply, so you just multiply things. And so we see there's no exponents outside of these, so that makes this one easier. At 4 times 3, looks like it'll be a 12. And then the x's, x cubed, x to the -4th, and x to the 4th. Well, what's nice is that these two cancel out, -4 plus 4, so it looks like it'll be an x cubed. Now, when we take a look at the y's here, okay. Let's see, well, I'm looking at it. Okay, so that takes care of the 4, the x cubed, the 3, the x to the -4. We have 3 take away 7, which is y to the -4th, but I can't have it there. I need to have it here. I have to make that negative positive, so that would be the answer for this one. Okay. Now over here, this is dividing. And again, we're going to apply these, but let me tell you, before you apply the 3 to things, see if you can reduce things. It would be a lot simpler. Because look, 6 and 15, we can have 2, 3, no, 3 goes into both of those. So that negative is ultimately going to go in front, but we'll, if it's needed, but we'll divide both of these by 3. So -2 over 5. I have 7 x's on top and 9 x's on the bottom. That gives me 2 x's on the bottom. Oh, these 3 y's will cancel out those y's except for one of them. That's 0 to the z, where z to the 0 is 1. So we just have a z to the 5th on the bottom. Now we can apply the 3 to each of these. So -2 cubed, -2 times -2 is 4. Times a -2 is a -8. Now, this is where I'm going to put the negative in front now, because I know I don't really need and shouldn't have it up on top. I should keep it as in front of it. 5 to the 3rd is 125. Then we have y cubed, x to the 6th, and z to the 15th. Now let's think about what makes polynomials. Okay? And so a polynomial cannot have a negative exponent. Okay, so I should say, shouldn't actually erase that. Okay, so that's the reason it's not a polynomial. Red. That's the reason that's not a polynomial. This is on the bottom, and that's the same thing as x to the -3, so same difference. That's why this one's not a polynomial. Not. They're all not polynomials, but I'll write it anyway. Not. Here, it's showing an exponent that's a fraction. So no, exponents have to be integers. Poly, something you didn't know before, and so I'll write and tell you. polynomials, put parentheses, polynomials exponents must be actually whole numbers because they can't be negative. Whole numbers. Okay, they can't be a square root either. Square root, by the way, a square root of x is x to the 1/2. And so if you look over here, okay, that's x cubed. Well, we'll change with it. But that means if I had the 5th root of x, that would be x to the 1/5. Notice that the root is the denominator. Okay, let's take a look at this next one, cube root of x cubed. Well, if I do that with x, and now the 2's on the bottom, it's that 3 that goes on top. Right? In this one, polynomials don't have the 2 variables multiplied to each other. In fact, you only have 1 variable. Okay. Multiply to each other. I guess you can have 2. I'm thinking through if we almost always just have 1, like x squared minus 5x plus 7 or something like that. But you can't have 2 variables that multiply to each other, else it's just not a polynomial. All right, now this next problem is really important because people tend to make an error with it often. This is subtracting. So what you're doing is 8x squared take away 5x squared, negative 7x take away 3x. Even though that's a plus, it's take away. And here it's 5 take away a negative 2. What I recommend is you use this to change the signs and literally just rewrite it. This is 8x squared minus 7x plus 5 minus 5x squared, because it changes it to a plus. Then this one becomes minus, and then this one becomes plus. Now you can combine the terms that are alike. 8x squared and negative 5x. That gives us 3x squared. The negative 7x and the negative 3x gives us negative 10x. And then, of course, the 5 and the positive 2, because now it's a positive 2, we get a plus 7. Okay, so beware of that. Watch out. Okay, lots of mistakes on that because people don't change every sign. Okay, be careful. Okay, let's see if I can get full letters here. Be careful of the minus or a little subtraction. Okay, and here's the same thing. If someone's listening right now, please go ahead and try this one yourself and then see if you're right. I'll give you, well, actually, I'll start talking in about 5 seconds, so you can turn it off and do it and then come back to it. Okay, now let's look at it. 5x squared take away 3x. Right, that's going to be a 2x squared. 12x take away a negative. I have to remind myself that's a positive. So 12 plus 8, then that means that should be plus 20x. And then negative 4 take away 7 sounds like it'll be a negative 11. You can do that in your head, but it probably would be easier if I had done this. Okay, let's get these numbers to work. If I had just changed it so that the signs were all correct, then 5x squared minus 3x, 12x plus 8x, negative 4 minus 7. To me, that's easier. I don't have to do it that way, but to me, it's easier. When you multiply polynomials, that's where the method is that you take the first one and you multiply it to both terms or more of the other one. Then this one times both. And then this one times both also. So what we get is 2x squared times 3x squared is 6x to the 4th power. In fact, I'm going to erase this because what I want to do is go through it. If I do each one, it helps me if I am moving the pen towards it. That's 6x to the 4th. And then this one is negative 4x squared. Then I am going to do this one times this, negative 15x cubed. And towards that, positive 10 x. Let me double check my negatives and such. Negative 5 times 3 is negative 15. Now there's 3 x's. Negative and negative is positive. Good, I got 10 and x. Then it would be this one times here and here. So plus 3x squared minus 2. Now those can be put in order, and some of them can be combined. So it's actually 6x to the 4th. Oh, it looks like it's minus an x squared. Minus 4 plus 3 is minus 1. Whoops, what I forgot is I need to put it in order, which means the cube has to go before it. Minus 15x to the 3rd. Okay, I've used those. Now with these two, that's going to be minus x squared. Now those are gone. And the other two don't have anything to combine with them, so that makes that easier. Okay, now let's look at the next one. Try to do that one yourself, and then I will show. 3, 2, 1. Okay. By the way, you notice the trinomials first. There's nothing wrong with switching it if you prefer, which I do, to put the other one here. Because this is multiplying, this is almost like 2 times 3, that's equal to 6. So is 3 times 2. You can switch them around as long as you don't change any signs. 1 minus 7, 3x squared minus x plus 9. So now this one times this is 12x to the 3rd. Here I have negative 4x squared. Here I have 36x. Now for this one, I'm going to put them right underneath it so they'll line up with each other. Negative 21x squared. Positive 14x. And of course there isn't one for this, but I can make that negative 63. So what I have here is 12x cubed minus 25x squared plus 30, 40, 50x. Interesting number. Minus 63. I just got to check on that. I'm wondering if I did something right or wrong. Let's just double check all the numbers here. So when I did this one, I got 36x. Okay. And then, okay, do I have more other x's? Well, I have. Okay, let's just double check. 12, negative 4x squared plus 36x. Negative 21x squared, positive. I was thinking of this too. I knew something was off. It shouldn't be. That's not a 14, that's a 7. Which means that's not a 50. So I'm glad I had a good instinct about that. 36 plus 7 should be a 43. And then take away 63. Okay. That's it for this section. There is more in it, of course, but these are the things I want to make sure you're comfortable with the multiplying them, especially dealing with subtracting the polynomials, knowing differences when they're not polynomials, and being able to work with exponents and A and B up here. Save this, and I'm going to say this is there. Save it to Algebra 2, essentially. And now you know to watch out for all of the little details about exponents and using them, and especially with the subtracting and the multiplying. The subtracting is probably the main place people make errors in this section. Thank you for listening, and I hope it was helpful.